And the x prime, y prime, z prime was created by dilating x, y, z. Right? The length of xy is 2, and the length of x prime, y prime is 4. So let's put on those information that we got. Xy is 2, x prime, y prime is 4. So we got those. 2 and 4. Now, let's see what we have in terms of questions. First question says here, triangle XYZ is image or pre-image? It is the pre-image. So this one is the pre-image. And whenever we have same letters, the image will come with the prime on it. So there is no prime on this right now, right? So it's the pre-image. That means x prime, y prime, z prime is image. It went further and it says the center of the dilation is one of these. So let's take a look. The center of your dilation is always a nice idea that actually connects corresponding points. If you should draw a straight line through the pair of corresponding vertices, so you could see the pair of corresponding vertices, they do converge at one location. All of them. This pair, and that pair, they all converge right there. So that's where the center of this dilation is. So again, if you should connect a straight line through the corresponding vertices, they will converge at the center of the dilation every time, right? So it is at O. So we saw that is at O right here. So we're going to tick O for this one. So that's O. Now let's take a look at the ratio for the dilation now. The dilation ratio, we could put scale factor here. The dilation ratio is also the scale factor. It is that number that is used to multiply your pre-image to produce the image. Yeah. So if we're going to find it, remember that the dilation ratio or scale factor can be found by having an image idea, and we're going to divide that by the corresponding pre-image idea. Has to correspond. So it's the image divided by the pre-image of any pair of corresponding ideas. So in order to find this number, we're going to have to go back to see what we were given. If you notice, we were given two things. One, we were given xy to be 2, x prime, y prime to be 4. So you're seeing where these are corresponding sides, right? So we're going to put things in context. X prime, y prime over x, y. Same letters. One is a prime. The image is on top, right? So 4 over 2, you break this down, 2 over 1, and we could say 2. The dilation ratio is a 2 to 1. Meaning, if I know my pre-image and I multiply it by 2, it's going to tell me the corresponding image for that. Multiply it by 2, we double. And what it also means is that if I have the image and I divide it by that thing, it's going to take me back to the pre-image. So if I have the image and I divide it by the scale factor, I go back to the pre-image. If I have the scale factor and I multiply it by the pre-image, it takes me to the image. So we could go back and forth. So in this case here, I want you to take note that this is image on top, and this here is my pre-image. And in terms of the numbers, for every 1 unit for my pre, it's 2 for the image. So it doubles. Alright? Now let's take a look at the third question here. The third question says, if the length of this, and they gave us that, y prime and z prime. So y prime, z prime, this is from my image or pre-image. Which one? It is from the image. So in other words, then, if I have the image and I want to go to the pre-image, what's going to be the approach since I know the dilation ratio? The ratio is 2. So I would multiply to go to the image. What do I do to come back to the pre-image? We divide by that same ratio. And that number would be, we're going to divide 2 root 5 by what? 2. So if we cancel this, we're going to get root 5. And that is equal to the line segment YC. Because remember, the moment we're coming back to the pre-image, you want to divide by that scale factor, all right, to go backwards. All right. The fourth question wants us to look at the ratio between this, xz over x prime, z prime. When you look at this, which one do we have at the numerator? Image or pre-image? Pre-image is at the top. So we're not just going to write 2 for the answer. We're going to have to make sure we're seeing what do we have at the top, what is at the bottom, so that we can put the numbers at the right places. If you go back here, you're seeing that when I'm dealing with 2 corresponding ideas, the pre-image is a 2. No, the pre-image is 1 and the image is what? 2. So in this case, we're going to put 1 over 2 because we reverse the idea. Pre-image on top of the image is going to be a half, right? But the other way around, it would have been 2 over 1. But this way, 1 over 2. Let's continue looking. What is the ratio of this now? So this one is a little bit more technical. They're asking us for y to y prime over O to y. These are not corresponding distances. So let's go to the diagram to have a visual of what it is. Here it is. So what they're asking us to do here is to write the ratio of this that I'm going to put in blue over this that I'm going to put in green. So they want us to compare the blue with the green. They didn't give us any number, really, and we cannot calculate these numbers. We're not on a grid. However, the dilation ratio is enough to guide us to think what is what. So let us look at what we know. We are aware that from O to Y is the distance of the pre-image from the center. This is the center. So from the center to Y. Y is the pre-image. Right, so we want to compare this distance, and then we're going to compare from the center to Y prime here. Y prime is here. Y prime is the corresponding point for Y. Now, if this, and I'm saying if this distance is 1 from the center to Y, what will be the distance from the center of the enlargement to Y prime, the corresponding spot?
2.
4.
It will be what?
4.
All right, he says 4. What do you say?
2.
2. Why 2?
Because the image is 2 times bigger than the pre-image.
That's it. Because the ratio is 2. So if this is 1, then this would be 2, right? So it doubles.
Okay.
Because it's corresponding, Y to Y prime from the center. But here is the idea now. Since we know that this would have doubled, how can we use that to answer the question? Because what we want to know is what is the ratio of the blue to the small green here. Where is this Y on the entire line? Where on the line is Y? Look at the numbers. In there? Exactly. Y is in the middle of the entire thing. Because remember, if all of this is 2, and from here to where Y is 1, 1 is a half of 2, right? So that means, let's take off this. Let's take off this here. So we are suggesting now that y is a midpoint, right? Y is a midpoint, it's in the middle. Now, if y is in the middle, right there, what is the relationship between blue and green? What could you say? They are what? How could you relate them since y is in the middle of this entire line here, some of it is blue, some of it is green, and they're actually like this. Y is in the middle. What would you say? How would you relate this to this? When you cut something in the middle, what do you get? You get two halves. And when you have halves, what would you say about each other? They're the same size. Now, can we conclude that the blue is the same size as the green based on this is in the middle? Mm-hmm. Yeah. So, if they are the same size, what about their ratio? Would one be bigger than one? No. If they are the same size? No. So, what would be their ratio then?
1 to 1.
They're the same. So, you could say 1 to 1, 2 to 2, 5 to 5, 10 to 10, 100 to 100. Whatever this is, this is. Because you did say it went down the middle. So if this is 1, this is also 1. So they're equal then. So based on the question here, this question is asking us to tell from y to y prime is 1. If this is 1, this is 1. They're equal, so the ratio is a 1 to 1. Got it? So for this one, so some of the times you gotta look to see what's going on. Based on the scale factor, we will be able to split up the lines and then make conclusions, right? So in this case, we saw that this is 1 to 1, because y is in the middle. All right, let's go to the next segment here. So in this segment here, it says, on screen, it says WXYZ and QRST are shown on the coordinate grid, where WXYZ is a dilation of QRST. That's the clue right there. We are using different letters, so there will be no prime. We don't have any prime in this. Prime only come when we are repeating a letter, right? We're not repeating any letters here, but the narrative of this sentence should have told us which one is pre-image, which one is image. Anybody want to tell me which one of these would have been the pre-image? Based on what you read here. WXYZ is a dilation of
QRS.
So QRS is what? Thank you. QRS is the pre-image based on the wording that we got. That means this one is our image. So in this case, we went from a bigger thing to a smaller thing. So we diminish. So this dilation actually let the image get smaller than the pre-image this time. All right? All right. We're going to use that to respond to a number of questions. All of that idea, what we're going to do here, we're just going to work out, all we're going to work out is the slope of the different line segments and the distance for each of those line segments. So we want to work out the slopes and then we're going to work out the distance. I'm going to move my screen. You're going to be working your slope and the distance beside it in the appropriate spot. But I'm going to be somewhere else so that you could see the diagram. All right? So the first one we're going to look at is YZ. So YZ, they're asking us for this. So we want to find the slope for YZ. Slope from algebra 1, you would have done slope and you use slope as rise over run, right? So slope is rise over run. So what we're going to do is stand at Z and we're going to rise until we are in line with Y and then we run to it. So we're getting a right triangle there. Rise, then run. Take a look at the rise over run. What are the lengths for these sides? What is my rise? How much? 2. What's my run? 2. So in terms of my slope, 2 over 2, which is the same thing as 1. So I wanted to put that at the appropriate place. 1. But remember, it's coming from 2 over 2. When you're ready to find the distance now from Y to Z, let us call this C. Remember that Pythagoras theorem right here. we can find C by taking the square root of the numbers from my rise over run. So it's going to be the square root of 2 square plus 2 square. What do we have there? 2 square plus 2 square is going to give me 4 plus 4. So we do have the square root of 8. Do we walk away and leave the square root of 8, or do we zoom in on it? Zoom in on it. How could I simplify this? Anybody?
4 square root of 2.
Find a perfect square, which is 4. So the root of 4 times the root of 2, and my final response is 2 square root 2. Excellent. So I'm going to put it on here. So this is 2 square root of 2 here. So the length of this side is 2 square root 2. What we don't want to do is a common mistake that I've seen. People tend to think that the slant line here is 2 units because it went across 2 diagonals. People tend to say 2 units. You can't. Alright? We only can count vertical and horizontal lines from the grid. But the slanted lines, Pythagoras theory, we work it out. Let's take a look at the corresponding line segment for this, which is, let me use a different marker for that one, which is ST. So we're going for ST. I'm going to put it in blue. So ST is right here. So we want to find ST here. Rise over run again, because we're dealing with the slope. What is the slope of ST? Anybody? 3. 3. So we're getting rise over run to be 3 up, 3 across. So this is 3 over 3. You could say 1 in the end. What about the distance of ST? Let's call this C. It is the slanted line. So I'm going to use my 3 and my 3. So the same numbers from my slope are what will be helping me to find my distance right there. So what we have here is 3 square plus 3 square. And what is that giving us? 9 plus 9, which is 18. Do I walk away and leave my 18, or do I try to see if I could break it down?
Break it down.
So what is the perfect square that we need? What is the square number?
9.
9. So we're going to break this into the square root of 9, the square root of 2. What's the final response? 3, exactly. 3 square root 2. And let us put it on at the right place. So 3 square root 2. Alright. So that's for that. We're now going to look at WX. While I clear the board here for space, WX, somebody could look to tell me what it is for WX in terms of rise over run. What are you seeing for your rise over run right there?
4.
All right, very good. So the slope, let me change the marker to identify it. We're using green this time. And rise, run, right triangle. We're seeing 2, 4. Excellent, right? So then my slope is 2 over 4, which is 1/2. Agree? And that's my slope, 2 over 4, 1/2. In terms of the distance now, the distance of we're still going to use that distance formula. I have the rise and the run from my slope, so it's going to remain the same. Square root of 2 square plus 4 square. This is going to give me 4 plus 16. Finally, this is the square root of 20. But do I walk away or do I try to break it down?
Break it down.
So how do we break down this now?
Square root of 10, and then the square root of 2, right?
Well, is any of those a square number? 10 and 2, can those work? Because we need to take the square root and get an integer.
4.
So 4 and 5, because we need to get that integer. So we are forced to use the square root of 4, the square root of 5. Square root of 4 is 2, root 5. So there it is that we have 2 root 5 for this distance here. 2 2 root 5. Let's do the other one on the other side here. Make sure we're taking that down. Is there any question relating to that? Or it's clear? Alright. Alright, so let us take a look at the other one. It's QR. Let's go purple. QR in purple. Right here. Rise over run. Anybody want to tell me what my rise is?
3 over 6.
3, yes. That sounds like it. So we're dealing with 3 and 6. So my rise over run here is 3 and 6. So that means my slope is 3 over 6, which is
2 over 3, right?
1 over 2.
1 over 3, no.
1 over 2. Agree? 1 over 2. Agree, sir? Everybody, we have 1 over 2. So 1 over 2 for my slope. And then for the distance from Q to R, so the distance QR is going to be what? Square root of those same numbers from the slope. So it's square root of 3 square plus 6 the square, and that's going to give us square root of 9 plus 36, which is square root of 45. Is there anybody who want to break that one for me? What are we going to use to break that down if it is possible? How are we going to break down that? We want to find this distance. 9 and 5. So it's going to be the square root of 9 times the square root of 5. Finally, we'll get 3 square root 5. So that's the distance here in purple. 3 square root 5. This one was 2 square root 5. So basically, as long as we have our slope, we're able to tell the distance of that line segment using the Pythagorean theorem, and we work it down, right? And whenever we have our radicals, we want to break it down, because when you break them down, you're going to see connections, you're going to see relationships. Look, root 5 for these. These are corresponding sides. Root 2, these correspond. So you could see the corresponding sides, there will be something in common, right, as we go. Let's go up. So basically we're at number 7. What it is we're required to do at 7? Number 7 is saying show the dilation of the coordinate grid by drawing dotted lines from the center of the dilation through the vertex. So the center of our dilation is 0, 0, right? Let me clear this off for us. The center of the dilation is 0, 0. What they want us to do is that we're going to just connect lines through the corresponding vertices, right? We're going to connect lines through the corresponding vertices, and we're going to take them through the center, to the center. Broken lines. So let's go. Let me use a red. So basically, Q corresponds with W, and we're doing a broken line, straight line through this. It's going to go to the center here. T corresponds with Z, broken line to the center. S corresponds with Y, broken line to the center. R corresponds with X, broken line to the center. And we are seeing that. That's where our center is. The idea for doing this is that if you have a pre-image and an image, and you want to find the center of that dilation, you connect 2 or more pairs of corresponding vertices. You draw long lines through them, and they will converge at the same place. It's called the center, which means that your dilation developed from there. This was where everything blew up or shrink from, okay? That's where the idea is coming from, right here. Are we good? All right. Let's take a look at number 8. Number 8 asks us to write a description of the dilation by giving the center of the dilation and the scale factor. The center of the dilation, we just saw that it was the origin, a 0, 0. So I'm going to write that statement, that the center of the dilation is 0, 0, and then otherwise known as the origin. We're going to try to figure out the scale factor now. It's a different diagram, so it's not the same scale factor, unless it's a coincidence. Remember, we're not dealing with the first diagram, we're dealing with the second diagram at number 6. So, we're going to have to try to find the scale factor now based on numbers that we got. So, how do we find the scale factor? The formula for your scale factor says, scale factor, we can find it by taking an image distance and divide it by a corresponding pre-image distance. It works, as long as they correspond. So remember that we could work with YZ. So we're using YZ over ST. So YZ and ST are related, they are corresponding. YZ was 2 the square root of 2, while ST was 3 the square root of 2. Is there anything here that we can cancel? Look, square root of 2. So if we cancel the square root of 2, the scale factor remains. We're left with what? 2 over 3. Now let us say that we never wanted to use those. Let us say we never wanted to use those 2. Let's look at the other 2 that we did. Remember, we did 2 more. We did WX. So WX was the image, and the corresponding pre-image for it was QR. Right? So WX was 2 square root of 5, while QR was 3 square root of 5. What can cancel here?
Root 5.
The root 5. So we could cancel the root 5 and we're left with what?
2 over 3.
2 over 3. So you do realize that we can find our scale factor using multiple ideas, but we must ensure that they correspond. What correspond? The image, the pre-image that we're using must be corresponding. And the image must be on top. So let us finalize the statement now. Let's go back to where the statement is. So the statement that we have here, the scale factor is 2/3. So the center of the dilation is 0, 0, and the scale factor is 2/3. Now, there is an algebra to this description that I'm going to put here, where if I know my pre-image coordinates, if I know my pre-image coordinate to be xy, as long as my dilation is at the center here, I can know what the coordinates for the image is going to be. All I'm going to do is I'm going to multiply my coordinates value by the scale factor. It works just the same. So if this is my pre-image, when I do this, I'll end up with the image idea. So we're saying that's the algebra for our dilation. The scale factor times your x value give you the image for the x. The scale factor times the y value from the pre-image give you the image for the y. Like this. So that is how you could go there easily. Alright. What is the ratio of OX over OR? Let us take a look on the diagram to see OX. OX, as you can see here, we're coming from O here to X. What is this distance here? 4. So OX is 4. And what about OR? What we getting? 6. Alright. So OX to OR is 4 over 6. Can you break this down?
Yes.
What do we get?
2/3.
2/3. You notice a connection here? Still seeing about the scale factor. That means these two distances are what? They are actually corresponding. From the origin from the center to X corresponds with from the center to R. And that is why we're getting back the same scale factor. So it's like that the original one shrink by 2/3 to form it. That's what it is saying. What about this one though? OX to XR. Anybody? What's the value for OX? We got 4. But if you go to XR, you're gonna get 2. This distance here is 2. So this one is 4. We saw that already. This one is 2. So let us put them on here. So this is 4 over 2. Can we break it down? 2 over 1, which is 2. So basically that is what I wanted for the homework.